Hi, I'm Craig Smith, a former New York Times correspondent and host of the podcast Eye on AI. I'm also a special government employee at the National Security Commission on Artificial Intelligence, and in this role am serving as the host for NSC-AI's podcast series on the Commission's work. This is the third episode of 6 looking at the Commission's second quarter recommendations to Congress. In the 2019 National Defense Authorization Act, the Congress established the National Security Commission on AI to consider the means and methods necessary to integrate artificial intelligence into the national security and defense needs of the United States. In this week's episode, I talked to Eric Horvitz, an NSC-AI commissioner and chief research scientist at Microsoft. We talked about his line of efforts recommendations that responsible and ethical uses of AI be a primary consideration in any AI system for national security. I hope you find the conversation as compelling as I did. If you could, Eric, introduce yourself and what you are doing at the Commission, and then maybe you could begin with a look back to the Commission's interim report in November and talk about the journey since then.
I'm Eric Horvitz. I'm serving as a commissioner on the National Security Commission on AI, and I've been particularly active in two what we call lines of effort. One on directions for research and development in AI, and the other on responsible and ethical artificial intelligence and practices around that. Looking back on this topic area, which is a very important one, we've come quite far since some of the general statements and important statements we made in the interim report released last November. In that report, we stated that defense and national security agencies must develop and field AI in a responsible, trusted, and ethical manner per core goals: sustaining public support, maximizing operational effectiveness, maintaining the integrity of the profession of arms, and being consistent with and even strengthening international cooperation and alliances. But we really called out this idea of preserving democratic values. We talked about our systems reflecting American values with having the rule of law at its core, and acting and using AI in ways that are consistent with constitutional principles, including due process, privacy, equal protection, and non-discrimination. We talked about the ethical and responsible AI being important for diplomacy, standing firm against uses of AI by authoritarian governments to repress individual freedoms and violating human rights. And we talked about the need for thinking deeply about this area from the point of view of the U.S. military in upholding laws of war and ensuring that the current frameworks that we have adequately cover AI. Moving forward, we've tried to go beyond high-level principles. There have been quite a few of these principles enumerated, even beyond our report. Around the same time as our interim report, the Defense Innovation Board issued a very nice report calling out a set of high-level principles for AI technologies on ethics and responsibility. Their principles highlighted were responsible, equitable, traceable, reliable, and governable. And these 5 high-level principles were actually signed into status as being DoD's principles just in February. And again, these high-level principles are fabulous starting points, but the devil is in the details of operationalizing these principles, going to the next level and thinking about what does it mean to build systems in accordance with high-level principles. In the last few months since November, our line of effort has been, with great staff support and collaboration by other commissioners and lines of effort, been thinking about a set of key considerations that we think will be important in operationalizing core principles, building and delivering ethical, responsible AI systems.
Yeah. Why considerations as opposed to recommendations? Is there any semantic nuance there? And then can you talk about those considerations and how agencies who adopt them can benefit from them?
Well, it's still early on in the field of what it's like to build and use AI systems. Things are moving very quickly. I want to acknowledge that responsible and ethical AI practices will be continuing to evolve. And like many technological advancements, it's really hard to identify now fixed or end states given the evolution of the area. What we did with identifying core critical areas to be thinking about was to frame important directions, to lay out a set of categories or an ontology for thoughtful consideration, to guide what we might call purposeful alignment. And we refer to the discussion and the details of the considerations as practices. These will be evolving as we move on, even as we head into our final report due out next year, into even more detailed levels of analysis aimed at implementation. For now, we call these considerations, and we wanted to get feedback from multiple sectors on the actual way we've divided up the area of responsible and ethical AI and the implications for moving forward successfully.
That's interesting. So will the considerations over time evolve into recommendations, into more concrete steps or actions? Or do you think that this whole realm is too imprecise and fast moving to make specific recommendations? It's more a matter of raising awareness of the issues.
Let me just say, first of all, that if you look at the section of the report on responsible and ethical AI, that we do get into quite a bit of detail in our considerations even now. I do believe we will have more specific implementation-centric recommendations in future quarters and in the final report. We called out in the considerations the area of values, engineering of AI systems, performance, human-AI interaction, on accountability and governance. And there's quite a bit of detail and important sets of challenges and opportunities in each of those areas.
On values, you talk about aligning values in AI systems. Can you talk more about that? Values presumably won't change. It's a matter of aligning AI systems to those values. And can you talk about why that's important?
It was very much explicit and deliberative, naming values first in the list of considerations. The idea of thinking through deeply from the get-go, when thinking about the role of AI and building an AI system capability, of thinking about why you're doing it, what's the goal, how will it act and behave in the world, and thinking deeply about consistency with core values for the goals and operation of the system. Will a system and its engineering act in accordance with privacy, goals of fairness, inclusion, human rights, the law of armed conflict? What does it mean to build systems that act in accordance with the U.S. Constitution that's operationalized in legislation? What does it mean for a system to treat data in a way that really is aligned with our principles and values around privacy? What does it mean for our systems to act in accordance with international treaties that we've ratified to be consistent with our commitment to human rights and human dignity? You know, we have sets of values and detailed assertions of these values in different sectors: Department of Defense, Homeland Security, the intelligence community. And I think that we have to make sure that these systems act in accordance with those specifications on values, starting at the high level. Now, it's interesting, we can start thinking about, in the context of values, notions of limiting activities or disallowing certain outcomes of what systems do in the open world, and think about how these behaviors can map to principles that are stated in law of armed conflict.
Can you give a concrete example of that?
Let me just pop up to a common consumer-centric example. Imagine an AI system is being used to control the steering actions of a car on the highway. It might be semi-automated or self-driving. You can imagine that we want the system to act in accordance with the speed limits in any location. We want to have limits on acceleration, on the rapidity of turns for human comfort. We might even want to follow recommended guidelines for poor weather that you might see on those yellow signs that say, it's not a speed limit, but we want you to go down to this other velocity when it comes to this curvy road or curvy road with poor weather. In the same way, we can ensure that our systems in national security applications never overstep bounds that are consistent with specifications as to behaviors that are allowed and desired.
Yeah. Last time we spoke, you made the point that in systems, AI systems, any system, really, there's oftentimes a trade-off between speed and accuracy or things like that. And that anytime you face a trade-off, you're basically faced with a value judgment. So can you talk about how things like setting thresholds on probabilities are actually value judgments and how values play a role in those kinds of trade-offs? In our quarter two report, we broadly break down value considerations into these broad assertions about democratic American values and talk about some of the core principles upon which our nation was built. We also then talk about engineering-specific value issues, which include how we manage trade-offs in our systems, such as changing thresholds or parameters that would shift, for example, the rate of false positives and false negatives in recognitions. AI systems often are working under uncertainty, and they're not always 100% accurate. For the most part, systems working in the open world with all the complexity have some kind of failure rate, and there are different kinds of failures. One kind is a false positive. For example, a medical system that might recommend to a doctor that a patient has an illness when they don't. It's a false positive in a recognition. A false negative is where an AI system might recommend to a physician after looking at sets of symptoms that this patient does not have an illness when they actually do. There can be different kinds of costs and significant costs with both kinds of failures. And it turns out in AI systems, you could actually change almost any system these days that's based on machine learning, change a threshold that will actually change the ratio of false positives and false negatives. Those settings might not be apparent from the get-go, but there are value assertions about what we care about and how we're going to distribute different kinds of costs. And they can have different implications for different groups of people, for example, that might be influenced by these systems. Another area for thinking through the details of values at the engineering level in AI systems is in the realm of the encoding of the goals of a system. These systems can be given explicit utility functions or value functions, mathematical representations of goals. And these value functions can have trade-offs. Let me make it more concrete. Back to cars again, talking about traveling with a GPS system in your car. You can have trade-offs in a value function. For example, it might be, give me the fastest route versus give me the shortest route. And more recently, we're looking at, can we compute safety? Give me the safest route. If you had a notion of a safest route, but the safest route was on a slower, longer course, you might say, I like safety a lot, but can I trade some of that safety off for getting to where I'm going in a quicker way? These, again, are value functions. You can imagine that systems working in the national security context, whether it be for intelligence or defense or other agencies, values can be specified in these utility functions and have powerful implications. We want these to become explicit and part of deliberation in building these systems. And you can imagine then in the military context, in lethal targeting, there'd be a similar trade-off that systems would have to face or that values would determine.
These are challenging issues, and thinking through the whole notion of minimizing civilian casualties or making that zero through the help of these systems, we want to make sure someday that we really understand the implications of use of these systems and that they're making the world better.
In your section of the report, you talk about considerations in AI systems that rely on representations of objective or utility functions, including the handling of multi-attribute and multi-objective models. Can you explain what that means to the layman?
Again, that's just what I was talking about a few seconds ago. The idea that you can have a representation of what we care about, what we want a system to do, and it might have several attributes or objectives, and that there might be trade-offs, and we want to make sure that we specify both the objectives and the trade-offs with clarity, and that we document and we're deliberate and we are mindful about the implications of building systems that operate in accordance with goals as specified by these representations. And one example was, again, in my car when I'm driving, if I just say I want to go somewhere and I don't want to look at all my settings, will the system give me a route that trades off distance and speed so that I basically can manage, say, my fuel as well as my time? Will it consider the safety of a route? Will it consider whether it's stop and go, whether it's highway driving per preferences? You can imagine encoding all your desires as a traveler in a car and having a system work to optimize what it thinks you want, even how you would trade off for your own preferences for speed and distance, safety and types of driving. And the same thing is true of systems, even if you're pursuing fairness. For example, you have to define what you mean by fairness. Let's say a system is being constructed that's assisting with recruitment and hiring, understanding goals to be fair when it comes to gender and age, socioeconomic background. In an attempt to be fair, sometimes there's a trade-off because you can't get everything at once. You have to define what it is you want and capture that with an encoding of preferences. What we say in our report in talking about the values, whether it be applied to fairness, bias, inclusion, or to operations of a system, trading off, for example, speed and accuracy. A core direction is to carefully encode the objectives, deliberate about them, make them explicit, potentially in many applications public, invite input from stakeholders, and document all of this.
You talk about tools for testing for bias and pursuing fairness in data and inferences and recommendations. What kind of tools are you talking about?
Our report is coming at a very nice time in that while it's early days in the thinking and directions for these important topics, we see the rise of usable and interesting sets of tools or tool chains for helping engineers and operators of AI systems to think through these issues and to be aided by software. Tools have been developed that can help developers and users of AI systems to understand and correct for challenges with fairness in a system based in data that potentially carries with it a long history of bias per the world it was sampled from. These tools can be used, for example, to understand and to visualize the potential challenges to fairness when it comes to socioeconomic background, race, gender, and age. And it's been great to see the rise of several different tools and approaches to understanding the behavior of our systems, where potential blind spots are, where potential challenges to inclusion is, and to help us build systems that are fair according to a definition that we would specify. In that there is not one definition of fairness, the tools also help frame the goal of writing down and specifying what the goal of fairness might be. For example, let's say our goal is we want to understand and to have the system act in a fair way along the lines of gender, women and men, when it makes recommendations. It might turn out that that goal is at odds with the goal of being fair to different levels of education or socioeconomic background more generally. We have to write down and specify what the goals are what the definition of fairness might be. And these tools can help us to encode as well as to see the implications of our definitions.
Yeah, and to make that a little more concrete, are you talking about, for example, you have a data set and through a visualization tool, you can see if it's imbalanced in gender or imbalanced in race, and that may affect decisions by the system, so you can augment one side of the data to balance it? Would that be an example of the kind of tool you're talking about?
You can imagine that approach or approaches that correct for potential biases in the data set at runtime by changing how inference works to assure a balance. Another kind of tool set that's coming to the fore are what you might say are checklists along the lines of checklists that a pilot might follow in getting his or her plane ready to take off. A checklist that might be used in a surgical setting in medicine, but having checklists to look at the data sets, the inferences, the use cases of how systems are being applied to keep a bunch of these subtle but powerful issues in mind along the whole AI development and fielding life cycle.
I mean, you've spoken a little bit about engineering of AI systems. Can you talk about what kinds of challenges you focused on with regard to engineering, the second area of your considerations?
We definitely want to refer people to look at our report, either our bridge version or our full Q2 report in the Responsible and Ethical AI section of the National Security Commission's second quarter report. In the engineering practices area, we call out the need to think early on about the design and requirements of a system and its goals, to spend time documenting the data sets, the algorithms, the models and their performance, the maintenance requirements, and also think through core infrastructure that's needed to support what the DoD has called out as being critical for responsible AI practices and systems: traceability, auditability, and forensics. Those kinds of capabilities, in some ways, just can't be bolted on as afterthoughts. Something that we've learned over the years in efforts with cybersecurity, you can't really layer on core functionalities as an afterthought in a robust manner. You have to identify key requirements of infrastructure to support instrumentation and tracing. In some ways, what we're trying to do is build AI systems that have kind of a flight data recorder in them, both for forensics and understanding what happened when, going back in time to understanding and making a system's behavior better, understanding errors and failures, and also in real time or near real time to understand what just happened. It's going to be important to build these systems from the ground up with these capabilities, and it can add quite a bit of engineering and infrastructure to doing it well. And therefore, we're hoping to see tools and best practices evolve that can be shared across agencies.
Yeah. And throughout the AI lifecycle, I mean, that's what you mean when you say as you're building it up, from the collection of the data, the preparation of the data, the building of the model, and the training.
There's the documentation and reflection, which is important, especially when you go back and to see what happened where, what data was used and its provenance. Can it be reused in different settings? Having efficient access to previous reflection and intention in our software in general, but AI in particular, is going to be important. Another area is the realm of security and robustness. So in the reliability and robustness space, we have to worry at engineering time on special aspects of AI systems that make them vulnerable to attack. There's a rising area of research in machine learning we refer to as adversarial machine learning, where we're learning about the brittleness of pattern recognizers and predictors and classifiers to various kinds of attacks. For example, modifying inputs very slightly in ways that people can see, such that we can change the behavior of a system. One great example that was shown early on in this space was a research team that gently modified in ways you can never tell as a human being an image of a stop sign to make it look like a yield sign to a pattern recognizer that might be used in a self-driving car. And these can be done in remarkably efficient ways, actually taking advantage of the same tools used to build the AI systems, these optimization methods that are trying to optimize now to break systems in surprising ways rather than make them better.
And there's also ways to poison the data in the training stage. Is that right?
There are whole different classes of adversarial attack, including, as you said, data poisoning, introducing subtle changes and certain patterns of data in the training set that lead to surprising behaviors, even in the embedding through training data of, you might say, certain patterns or codes that could be turned on by patterns of input by an adversary. The good news is that there is ongoing research in this realm, including work on what's called robust machine learning that's less brittle to these kinds of attacks. There are other kinds of mitigations that we call out and reference in our report, including best practices on how to handle models, how to keep them privileged and secure. And the area in general of mitigating against adversarial attacks is important. In the engineering section of our report, we want to highlight the critical directions here, the critical importance for national security of developers and users of AI systems to be aware of these potential brittleness, these potential failure regimes, and to be ready for failures, as well as to be working on mitigations and keeping up with the research in this space.
Yeah. And what we're talking about right now is hardening national security systems to that kind of attack. Conversely, those kinds of attacks could be a pretty effective and powerful offensive weapon against adversaries' AI systems. There's so much open source work on this. Is there classified research underway in how to both harden and use adversarial attacks as an offensive weapon? It seems that you would want to take it out of the open source realm if you were going to apply it to national security.
Let me say that I can't comment on cleared work in this space. My first priority as a chair of this line of effort was to call out the importance of national security agencies keeping up with the latest in open research on adversarial machine learning, and to realize that with all the value that can come with AI systems, with growing reliance and the growing ubiquity of these systems, we're rolling out new kinds of attack surfaces that we need to protect and be aware of in terms of the potential for brittleness and attacks. At the same time, you can imagine this is an interesting area for thinking about what does it mean to be an adversary when it comes to strengthening one's own position with regards to other AI systems used by potential adversaries. But the focus here in this section was how can we make our systems more robust and reliable by understanding deeply the concerns, working on mitigations today when it comes to potential classes of attack like data poisoning and other kinds of challenges that we call out in this section on adversarial machine learning. Another area that's going to be very important is red teaming these systems to really expose them to creative attacks of various kinds using the latest and greatest tools before we release them into the open world and into open uses to make sure that we're up to speed on the deep and broad world of creative attacks, sometimes outside of the things we're thinking about.
Can you define red teaming for those listeners who might not be familiar with the term? And is it essentially turning white hat hackers loose on a system?
Essentially, yes, we can have professional red teams that act as if they are the adversary, and we give them broad rights to go after what they might find as holes in our systems to expose various kinds of vulnerabilities. At times, we can open systems up more broadly, the way that things tend to happen these days in the commercial IT community, to even give out rewards to break systems and to continue to hammer on them to make sure that they're safe. But we'd like to see a rich ecosystem of red teams that learn about and are the best of breed when it comes to, for example, adversarial machine learning attacks of various kinds on national security systems, so as to understand vulnerabilities in our systems and make them better.
Is there a plan to formalize that, to engage academic institutions to create formal red teams for national security purposes? Or are there plans to have, or are there red teams within the DoD at the moment who are tasked with that work?
In our quarter two report, we simply call out the importance of red teaming. We don't go into a great amount of detail as to process and procedures and requirements on that. Similar to other areas or considerations, we want to call out and at this point in time, describe the need and describe how this might work, as opposed to saying this is exactly the requirement or recommendation on how to implement red teaming.
Where do you expect this line of effort to go in the current quarter?
There is clear interest on our line of effort with my fellow commissioners there, as well as staff, as well as the broader commission, with looking at where we are with these considerations and for each thinking through what we might say in terms of more specific implementation-centric guidance as we move into the next quarter and into the final report. I was content personally with laying out these key considerations as 5 important areas to go to the next level from the high-level recommendations we see being issued by numerous organizations, including the Department of Defense. Getting to the next level, you realize that the opportunities and challenges are really in the details. And that's where the rubber meets the road, and that's where we have to do a bunch of work. The question is, for me and for staff and my fellow commissioners, where are things mature enough now in the realm of responsible and ethical AI, whether it be in the values, in the engineering, the performance area, the human AI collaboration space, or accountability? Do we know enough now to get even more specific than we are in the current report?
Yeah. Okay. Well, I'm out of questions. Is there anything we haven't talked about that you would like to raise for listeners?
I would refer listeners to all these considerations and take a look at them. We're very interested in hearing feedback from multiple sectors, including the broader public of people who are interested and have ideas to share. We didn't talk a lot about our section on performance, which we called out as a separate area from engineering, given concerns with using AI systems in the open world and continuing to monitor them and evaluate them, test and validate them as they move in different contexts, for example. We didn't have a chance to talk in our podcast today on this really rich area of human AI interaction. So we didn't talk much about human AI interaction. This is a critical area. People are at the center of AI systems and development and should be at the center of their use. We want to think deeply about the role of people in human AI interaction, looking at people and AI as a larger system. We want to understand how to build AI systems that really support human beings, that augment their intelligence, that help them make better decisions. Part of this is thinking through how to make systems clearer in what they tell people. Can they explain themselves better? Do they have interpretable reasoning? We recommend that AI systems provide confidences in their reasoning, well-calibrated confidences as to how confident an AI system is about a recommendation, so they understand how to weigh their own intuitions and insights with machine guidance. There's a really interesting area of what we call a mix of initiatives. How does a machine hand off control to a human? How does a human operator pass control back in what might be viewed as a dance between human and machine intellect for having maximal impact? And we want to understand how to best train people to use AI systems effectively over time, keep them up to date, and think through deeply training programs across agencies.
I've heard people starting to talk about, rather than an operator and a tool, as AI and the human working as a team with communication going back and forth, so that it's not that the AI makes a decision or offers a recommendation and then the human acts on it, that there's more of an interplay between the two.
Thinking through how to do that with elegance and fluidity such that you're really creating or supporting and nurturing a smarter, more competent human decision maker, I think is a critical opportunity of our time. While we're on people, let me just end by calling out our last consideration, which was on accountability and governance. I recommend folks take a careful look at our section on accountability. We call out the need to have the AI buck stop with people. The buck has to stop somewhere. And we recommend that human beings as a practice are responsible for the behavior of AI systems, whether it be the operator or someone up a command chain or an organizational chain, that human beings are always held accountable for the actions of AI systems.
That's it for this week's podcast. I want to thank Eric for his time. If you want to learn more about NSCAI's work, you can find them on the web at www.nscai.gov. We love to hear from listeners, so feel free to contact us with comments or suggestions. And remember, the singularity may not be near, but AI is about to change your world, so pay attention.